So hopefully by now you're recognizing the sort of usefulness that scripting in Python can provide for your Grasshopper definition. But there's two particular aspects to scripting within Grasshopper that become really powerful and really useful. And one is the ability to actually integrate this scripting with the rest of your existing workflow. So we don't have to think about creating all of our geometry or all of our operations with a script or in text. We can actually just input it very specific places just to do things that are maybe difficult or clunky to do in Grasshopper itself. And the way to do this is basically by using the input and output logic within this Python node. So instead of declaring everything here, we can actually pass a lot of our variables and all of our data straight into these input nodes. And then the results that we generate through the script, we can assign to these outputs. And this is really simple. It works exactly how you would think. We have these inputs. We can pass any piece of data into here. I'll just pass the integer 2. And now I can reference this x as a piece of data that's within my function. So passing something to x works exactly as if I had declared a variable called x and then assigned it to 2. So here x is now referenced within my script. And if I get rid of all this, I can actually start to work with that data that I'm passing in. So I can print x, go to test, and now it prints 2. And the outputs work exactly the same way. So here I have an output declared as a. You can create a panel to just visualize what's coming out. Right now there's nothing in it because I'm not storing anything in a. Start by assigning a to x, so I'm just passing what's going into x and assigning it back to a. If I hit OK, you can see that a is now 2. And this works with single values. It also works with list of values. So here I can declare a list and say I'll pass x into a list 3 times, go test, and see now a is being output as a list of values that's totally integrated with the way that Grasshopper already works with list of numbers. So this is the first kind of key advantage of scripting within Grasshopper, is that you don't have to do everything through scripts. You can just integrate it with your existing workflow. The other real power of using scripting within Grasshopper is that you can not only work with a standard piece of data like text or numbers, you can actually work with geometry from Grasshopper or from Rhino. To do that requires a small additional step, which is learning the syntax for how objects are stored within Grasshopper and how you can reference them within your script. And this functionality is not built into the standard Python. Python by default will handle all the things we've talked about so far, like conditionals and arithmetic and different logics. But by default, Python is a general programming language and doesn't come built in knowing how to work with Grasshopper. To do that, there's basically external libraries which you can import into Python, which will bring in specific functions to allow you to work with geometry. And this idea of creating libraries to extend the functionality of Python is a really powerful idea, and it's really what's made Python a really popular program language, and it's why it's being incorporated into a lot of tools, because it could be used in Rhino and Grasshopper with the special Rhino libraries, and then it can also be built into Maya, and there you have special libraries that allow you to work with its particular software and geometry. So to import libraries into Python, we use the import keyword. And once you type this in, hit spacebar, you can see that there's a kind of a pop-up tool that shows you all the libraries that are built into the system that you can reference. So that includes some Python-specific libraries. It also includes some libraries that are specific to Grasshopper and Rhino. So here you see the Grasshopper Python library, Grasshopper. Down here you'll see Rhino script syntax. So you can think of this as kind of layers upon layers. At the base, there's Python and all the syntax to structure your code. And then on top of that, you have these libraries that are written by the people who make Rhino to help you connect with Rhino and Grasshopper. So this can get a bit complex, knowing which library to use at the right time. And all of these libraries, all of these Rhino libraries are useful to some extent. But I'm just going to go through and show you the basic setup of referencing geometry and what libraries we need. To do most of our operations, we're going to use Rhino script syntax. And to reference it, you can just double click on its name in the list. You can also start just typing, and then once it's highlighted, hit enter. So this will import Rhino script syntax, which will come with a series of functions to help us work with Rhino geometry. And as a shortcut, so we don't have to type out Rhino script syntax every time we use a function within the library, we can say import that library as rs. So rs now is tied to this, and instead of writing this whole thing every time we want to access one of its functions, we can just type rs. So that'll perform the import, and now we can use all the functions within that library. So I'm going to exit out of this, and the first thing I'm going to do is import a couple points from Rhino and show you how I can reference those points within the Python node and start to work with that geometry. Okay, so I'm just going to create 2 points in my Rhino window, and then I'm going to create 2 point nodes to reference those points in Grasshopper. Okay, so here are my 2 points. I'm just going to input those points into my Python window just like I was doing with numbers. So now I'll open up my Python script, and to start off with, if I pass my input to the output, so here I'm just passing that point from x to a, you can see that Python has stored that point as just a series of x, y, z coordinates. So if you do this with points, Grasshopper's smart enough to realize that a series of x, y, z coordinates is a point, so it's actually going to preview as a point in your window. The nuance here is that Python itself doesn't actually know that this is a point. It's just being input as a series of coordinates. To work with the point itself as geometry, and then also more complex geometry like surfaces and lines, you actually have to take this reference and find the specific geometry that's referring to. So I'll show you what this means. Basically, if we print the input right now, so x is storing our point, and we're just printing out x, and we go to test, you can see what prints out is not a piece of geometry, it's actually this unique identifying number. And these unique identifiers, you might have seen these before, this is actually how Rhino and Grasshopper store geometry. So any piece of geometry in your document has this unique identifier, and it's actually the method that Grasshopper uses to connect to Rhino geometry. So here's a point, it's actually referencing this point in Rhino using this unique identifier. So that's actually what's passed into Python, and that's what Python's going to work with. To work with the geometry itself and manipulate it and create new geometry, we need to reference the actual description of geometry that's tied to this unique identifier. And for that, we can use a Rhino script syntax function called coerce geometry, which will use that reference to pull the actual geometry from the Grasshopper document. So in this case, I'm going to make a new variable called point1 equals, and now we'll type in rs, and that references our library. And once you type in the dot, you're actually going to get a preview of all the functions that are built into that library. This is really useful for you to kind of see what's available for you to work with. Okay, so part of this library is the coerce function. So if we start typing in coerce, it's going to go to that point in the function list. And here you see a lot of different ways, a lot of different types of geometry you can coerce. And this is basically, you can think of it as a way to tell Python what kind of geometry you're passing into it. So in our case, we're working with points. We're going to use coerce 3D point. Once you type it in, it's going to go to it. You can hit enter. And into this function, we're going to pass our input, say x. And now we'll print our point. So you can see here we have the reference, and now we have the actual 3D point coordinates. Okay, so we're going to do the same thing for our second point. Go to coerce 3D point and pass in our y input. And now we can work with this actual geometry to create new geometry in Python. So what I'm going to do is create a line. So here, line is just a variable to store that new line. And I'm going to use another Rhino script syntax function to create a line. For creating geometry, we use the add syntax, and here you can see all the different geometry that you can create within Rhino. So we want to create a line, so we go to add line, parentheses. Once you hit open parentheses, it's going to give us a description of that function, including the name and then what inputs it's expecting. So here you can see it expects 2 inputs, a start and an end point. So we're just going to pass in our point 1 and point 2. Now line contains that line, but in order to work with it and pass it out of the Python node, we need to assign it to one of the outputs. So we're just going to assign A to be that line. Here we hit OK, and you see A is now this line-like curve. It's actually a piece of geometry in Grasshopper, and we can pass it out of here and work with it. This is working just like any other Grasshopper node. Now if we move these points, you can see that the line reacts to that movement. Okay, so you can see now that just with one additional kind of step, we can reference actual geometry within Python and work with it in the script.